Sir, good morning, sir. Good morning, Kishor Kumar, sir. Sir, you have muted your mic, sir. I can't able to hear your voice, sir.
Yes.
Yeah, fine, sir. Good morning, sir.
Good morning, ma'am.
Yeah, sir. Sir, we just wait
Good
for
morning, good
5
morning,
to
Kishor Kumar, sir. Good morning.
7
Good morning,
minutes,
sir.
sir. So participants are joining, sir. So we just wait for 5 to 7 minutes, sir. Sharply at 10 o'clock, we can
Okay.
start.
I am adding my screen. You ensure
Okay,
that
sir.
whether it is coming or not.
Yes, sir. I will tell, sir, whether it's visible or yeah. Yes, sir. The first slide is there,
Okay.
sir. You can just make it as a presenting mode and you can just
Okay.
hide that screen, sir. Like hide icon, you can just press and you can just.
Kishor sir, I think you will start.
Rajan sir?
Yes,
Yeah,
sir.
you can just give an introduction about
Yeah, sir. Yeah,
Mr.
welcome,
Kishor
sir.
Kumar, and then you can start.
Yeah, sir. Thank you, sir. Good morning to one and all present here. So let us start the day one of session one of STTP Phase 2 program. So I welcome Mr. V. Kishor Kumar, sir, who is an assistant professor in the Department of Civil Engineering at KCG College of Technology. He obtained his master's in soil mechanics and foundation engineering at the College of Engineering, Guindy, Anna University. His master dissertation topic was related to characterization of bentonite cake formation and his influence on the interfacial friction between pile and soil. Presently, he is working on response of foundation elements embedded in reinforced sandbed under axial compression and uplift for his doctoral study. He has 10 years of academic experience and more than 20 years of industrial experience in organizations like Lanson and Turbo, Afghans, and Tamil Nadu Public Works Department. He has involved in projects like East Coast Road Project, Sambalpur Road Kela Road Project, Vadora Baroque Road Project, and World Bank aided modernization of minor irrigation tank in Tamil Nadu. Also, he is a life member in Indian Road Congress, Indian Geotechnical Society, a Chennai chapter, and Institution of Engineers, India. I welcome you, sir. I just hand over the session to deliver your lecture on the topic soil characterization and testing for road construction.
Yeah, nice introduction. Sir, you can start, sir.
Thank you, sir. This session, uh, this is related to soil characterization or soil uh, understanding soil, and related to road, the soil related to road. We will discuss something about how it is being constructed, then quality control aspects and all. So the presentation will be like this. We will understand what is soil, how it is being formed, and what are all the relationships, not in detail, in a crisp phase, like a phase relationship, how it is being related. Then what are all the procedures available for classifying the soil and how it is being characterized, soil being characterized. Then we will see how the road being constructed, what are all the methods they are adopting, and how it has to be done based on MORTH. Whatever I am presenting here is based on Ministry of Surface Transport document, it is specification for highways and bridges, standard specification. So we know soil. Soil and we engineers, we will see and we will see the aspects of soil in a different way. For example, the geologist, it is the mineral materials which is available, which is on the earth surface, and whatever balance it is available below, they call it as rock. That's all. They only concentrate on mineral content available in the soil. So that is their part of interest. Then the pedologist, it is the substance existing on the surface which supports plant life. They are interested only up to the depth up to which the roots are penetrating. So for them, that is the soil portion. For us engineers, we are more concentrating, or we are more interested on engineering properties. To understand the engineering properties, we have some index properties and other tests. Based on that, we will conclude, we will construct, we will build on foundations, foundations of buildings, bridges, basements, culverts, tunnels, and embankments, road, dams, retaining walls, etc., on the soil, which is which has to be supported by the soil. Basically, the formation of soil, we all know, it is basically the formation of earth surface, igneous rocks, sedimentary rocks, metamorphic rocks. I'm not going into that. It's igneous rock is solidification of molten lava, and sedimentary formation, and it is because of rock is being formed over and over the sedimentation, then we call it as sedimentary rocks. Metamorphic, due to the enormous pressure, the soil mineral get changed into another form. Then we call it as metamorphic rock. Soil are formed from material that have resulted from the disintegration of the above rocks. So depends upon the parent, the soil particle will behave or will possess these properties based on the parent thing. Say for example, igneous rock, sedimentary rock, metamorphic, whatever the mineral content which the parent rock possesses, the particles will be dominant in that minerals. And it also undergoes physical and chemical weathering during the being in the thing, when it is being carried away or it is being exposed to sun and rain. So it is been weathered by physical and chemical weathering. The nature and the structure of the given soil depends upon the process and conditions that formed it. What type of how it is being formed depends upon that the property will change. Say for example, if it is been formed by breakdown of parent rock, by weathering, decomposition or erosion, or transportation to site of final deposition based on gravity, if it is falling from a hilltop to the toe, or flowing through the river carried by the ice and wind, then environment of final deposition, if it is a floodplain, river terrace, glacial moraines, lacustrine or moraine, whatever may be the environmental conditions it is being deposited, based on that also the properties will change. Subsequent conditions of the loading and drainage condition will also influence. Little or no surcharge, if the soil presence on the surface, then it may have lesser strength. If it is been heavily compacted, the surcharge been applied over the long duration, then it is being compacted and behave as a dense one. Due to ice or overlaying deposits, the surcharge may be due to the ice formation or deposits on over and over in the rivers like that. Then change from saline to freshwater. Then because also leaching some chemicals or calcium rocks, if it leaches, then also the properties will change. Say for physical weathering, reduces the size of the parent rock material. Most of the rock particles caused due to a mechanical collision between the rock bigger particles, then it becomes finer particles, or most of the earth soil particles formed by physical weathering due to sun and rain, continuous sun and rain for millennium of years together. So this rock material, without any change in the original composition of the parent rock, they cause disintegration, and the products are mainly coarse soil. Chemical weathering not only breaks up the material into smaller particle, but alters the nature of the original parent rock itself. The main process reasonable are hydration, oxidation, and carbonation. The compounds are formed due to chemical alterations. The particles which is been formed by physical weathering, we call it as coarse grain soil or coarse soil. The particles or soil which is been formed by chemical weathering, because the mineral itself is getting altered because of the chemical influence. So we call it as fine grain soils. Soils as they are found in different regions can also be classified into broad categories. Depends upon the position of the soil. If it is been on the same place, it is been formed on the same place and it is residing there, then we call it as residual soil. Good example is the soil which has been available on the foot of the hill. We can call that as a residual soil. And transported soil we can see in delta regions that are transported from elevated portions to delta regions lower levels by the flow of river. Residual soils are found at same location where they have been formed. Generally the depth of residual soil varies from 5 to 20 meter, comprises of a wide range of particle size, shape and composition. There are many transporting agencies. It can be a combination of thing, gravity, flowing water or air, and moving icebergs. If it is transported, the gravity transports material along the slopes without causing much alterations. Some alterations may happen because of colloidal things, mechanical collision. Then second type of deposits are alluvial deposits. Alluvial means it is being carried by the river and it's being deposited on the river banks or sites. This is a suspended particles or by rolling and sliding along the bottom. Coarser particles settles when the decrease in velocity occurs, where fine particles are deposited further downstream. In still water, we call that deposits as lacustrine deposits. Say for example, the example of a still water may be a lake or pond. The deposits below that on that bed we call it as lacustrine deposits. Horizontal layers of successive sediments are formed, which may change with time, even seasonally or daily. This we can see if we cut across a river bed, we can see the particle variation, stratified deposits. We call that as stratified deposits. Say for example, on a rainy season when the velocity is high, the particles depositing will be larger particles. And in the summer season when the discharge gets reduced, the velocity is also get reduced. So the particles deposits over the coarser particle, the fine particle will get deposit. And again subsequent rainy season, the coarser particle. So this is a stratified thing which is prevails on the river beds. We call that as stratified deposits. But on the other hand, in alluvial deposits, wind is the phenomena which carries the particle. It sorts the material. Wind carried out transport and deposit fine soils. Wind blown soils is generally uniformly graded soil. Uniformly means what wind does, it sorts the material. Coarser particle will fall nearer to the residual portion, that is parent rock. Then the finer particle will be carried away to the larger distance. So the deposit which is on the larger distance will be even size and it will uniformly graded. We call that as uniformly graded. The particle size will be almost same. Same means which will have a narrow window. And the particles which is you can this is a sorted deposits. And these deposits will have lesser strength when compared to homogeneous well-graded deposits. Glacial deposits has a different character. What glacial does, when it forms, in winter it is being formed at an hilltop, glaciers are being formed. When summer comes, the total glacier along, when it forms, it occupies, it covers the bigger polder to smaller particle, everything it gets covered. When it summer comes, it slides and it travels on the river, and when it gets melted, all the particles which is being coarser and finer deposits on the same place. We call it as erratic deposit because you will find all the size of particles on the same place, and understanding the behavior is also difficult for these type of deposits. Another type of deposits along the sea coast and river delta regions where the sea and river interacts. Here the tides and the waves transport the particles. The deposits are made by river in seawater. This contains both particulate material brought from the shore as well as organic remnants of marine life forms along with the salt present in the sea. So the salt also which will have a chemical action along with the soil, and it influences the behavior of the soil in marine deposits. And since the marine deposits, there may not be so much of surcharge, and these deposits will be very loose or soft. So this will be having problematic. Most of the marine deposits are problematic deposits. This is a thing figure which we can understand. We try to understand how the soil is structure is. So it will be if you see the first box, you will see the particle, bigger particle, smaller particle, and it mean you will have air gap, voids. We call it as voids. So normally in other material, that for example steel or other man-made material, we can assume that as a total solid, and the behavior also consistent. Since it has all the material, it has solid also. When the water table is coming and interacting, or it is filled with the voids are being filled with water, when it filled partially, it behaves differently. When it filled fully, we call it as saturated. Then the behavior is entirely different when comparing in comparison with partially saturated soil. And we have, when the full voids are being, the water is being removed, and then the voids will be fully occupied by the air. We call that as soil as dry, fully dry soil or dry soil. This fully saturated and dry soil mostly behave similarly, but the partially saturated soil behaves differently because the saturation percentage differs from 0 to 100. So when it differs, automatically your behavior also changes based on the percentage. We have relationship to understand the behavior or define the things, parameters. We have volumetric relations, weight relations, and interrelated volume and weight relationship also. Say for example, volumetric relations, we have void ratio, porosity, degree of saturation, air content, percentage air void. All these things are volumetric relation. Then we have weight relation, mainly water content, that is called weight relation. Then we combination of these two, we call it as unit weight, dry unit weight, saturated unit weight, bulk unit weight, submerged unit weight, and specific gravity, and also relative density is also another one parameter which is being defined. We can, so that all these properties are index properties. From these index properties, we can understand how the soil will behave or what is the state of the soil. When we see, say for example, when we have water content 0, then we imagine that soil is in hard condition, or the strength of the soil will be relatively more when it is being fully saturated. So that is why this is an index property. These properties are called index property. Based on the index properties, we can we can judge the behavior of the particular soil. Say for example, void ratio, it defines the volume of voids, how much volume of voids which is being presented in the soil. So if the voids is more, automatically your solid portion will be lesser. Automatically your soil will be lower strength in comparison with the densely packed. Densely packed means automatically your void ratio will reduced. So like that, each parameter will tell you some information about the soil. When it comes to define the soil or classify the soil being mainly broadly classified into coarse grain soil and fine grain soil. And within some forest areas and in agricultural areas, since because the organic matters, that organic content being deposited and the soil is fully rich with organic content, then we call that as organic soil. So broadly classified as coarse grain, fine grain, and organic soil. When we call that soil as coarse grain soil, for which we have to perform sieve analysis, our window sieve is 75 micron, that is 0.075 mm sieve we have to take. We have to sieve the sample which is being collected through the 75 micron sieve. If the particle, that is the portion which is retained, is higher, more than 50%, Then we call the total soil as coarse grain soil. Say for example, if the retained portion is 51%, this is by weight. So if the retained soil is 50.1% and the passing soil is 49.9%, then also we name that soil as coarse grain soil. Similarly, when the percentage passing is more than 50%, then we call that soil total as a fine grain soil. Then from again the coarse grain soil is being fine again subdivided, and we will give a sand and gravel. We can call that sand and gravel. The fine grain soil is again we call that as silt and clay. Depends upon the particle size. There are various classifications, unified soil classification systems, American Association of State Highway and Transport Official System, Indian Standard Soil Classification System, Massachusetts Institute of Technology, then American Society for Testing and Material. These are all the systems they have. For example, in America, they have ASTM for other purpose and ASTO for roads and roads related structure purposes. In India, we follow Indian Standard Soil Classification System, which is almost similar to Unified Soil Classification System. So this Indian Standard Soil Classification System based on USCS with some little modifications. The basis for the ISSCS, that is Indian Standard, is that coarse grain soils can be classified according to their grain size distribution, whereas the engineering behavior of fine grain soils is primarily related to their plasticity. So that is how we define our thing. What are all the information we require to classify? We require grain size distribution, for which you have to perform sieve analysis through set of sieves. Say we have to know how much percentage passing through 75 micron sieve and how much retained on 4.75 mm sieve. This information we require. And we also require CU and CC is uniformity coefficient. CC is coefficient of curvature. Then we should also know Atterberg limits, which is such as liquid limit, plastic limit, shrinkage limit, and its products, plasticity index, which is plastic limit minus liquid limit. Then consistency index, liquidity index, all these properties we require to understand the behavior and classify the soils. This is a scale which will tell you this is less than fine grain soil, silt and clay will be below 0.75 mm, that is lesser than 0.75 mm. And if you call a soil is a boulder, then the size of the particle will be more than 300 mm. Then between 80 to 300 mm, we call that particles as cobble. And if it is less than greater than 4.75 to 80, we call it as gravel. If it is between 20 to 80 mm, then we call it as coarse gravel. If it is between 4.75 to 20 mm, we call it as fine gravel. In sand, we divide this total into three parts: coarse, medium, fine. If the particle size is between wherever I am saying this particle size, it should be more than 50%. Say for example, coarse sand. Coarse sand means the majority of the particle, that is more than 50% of the particle weight should fall between 2 to 4.75 mm. Then we call that as coarse sand. Similarly, medium sand. Similarly, that is medium sand is between 0.4 to 5 mm. We call it as 425 micron to 2 mm. Then fine sand, we call it as 0.075 to 0.425 mm. Then we have some symbols also to define the soil. G for gravel, S for sand, C for clay, and O for organic matter. But for silt we have M. That's the only difference. So we can easily remember the symbols. So in coarse grain soil, if it is a coarse grain soil, so soil will have both coarse grain portion as well as fine grain portion. So you have to perform both the sieve analysis. For the coarse grain portion, we have to do sieve analysis. For the fine grain portion, we have to perform hydrometer analysis. In detail, see, if I am taking 500 grams of soil, if my retaining, I am washing that soil through 75 micron. When I wash the soil 500 grams of soil, then 249 grams of soil passes through the 75 micron sieve, and the balance 251 grams is retained on the sieve. We call that as coarse grain soil. Then retained portion 250 grams will be conducted. The sieve analysis, mechanical sieve analysis has to be conducted. The passing soil, which is 249 grams, for which we have to conduct hydrometer analysis, because we cannot perform sieve analysis because the particle size is getting reduced, and it will have binding property also. So the particles will get bind one to one another, and it will show us bigger size. So we have to analyze on the we have to treat that soil by some dispersion agent. Then we have to perform hydrometer analysis. So along with that, we have to perform this consistency or Atterberg limits, such as liquid limit, plastic limit, shrinkage limit, from which we have to find out plasticity index. So based on your grain size sieve analysis, we have to plot the graph in a semi-log graph sheet. Horizontal axis will be a log scale and vertical axis will be a normal scale. We have to plot the thing. If it is a smooth S curve, flat S curve, we call it as well graded, because it will have it will have all the size of the particles in that particular soil. We call it as well graded. If we have only one size between the window is very less, then it will be a very steep S. So that is called uniform graded soil. We have two parts of soil, which is one coarser size and one finer size, and in between there is no material, there is no particle size. Then we call that as gap graded soil. So one can ask, which soil is a better soil? Yes, automatically well graded soil is the good soil for engineering purpose. And uniformly graded soil is a poorly graded soil. Automatically it is well graded means automatically it is poorly graded. So for that you have Cu and Cc, the formulas are, you have Cu is equal to d60 by d10 and Cc is equal to d30 square by d10 into d60, and d10, d30, d60 are the particle diameter, corresponds to 10% passing, 10% finer, 30% finer, and 60% finer. So you have to take that value from the log semi-log graph, then substitute, then we have to find out the value. From the value, if it is a gravel, majority gravel soil, then your Cc value for sand and gravel, Cc should be between 1 to 3. And Cu will only vary. If it is a gravel, then your Cu value is more than 4. Then we call that as well graded. If for sand, if your Cu value is more than 6, then we call that as well graded. Well graded gravel or well graded sand. If these conditions is not being satisfied, any one condition, say Cc is less than 1, but Cu is more than 4, then also it is not satisfying. So that soil is called poorly graded soil. So this is a graph figure which shows how the soil being can be classified. So you have to perform a sieve analysis. Then from the sieve analysis, if the percentage retained is more than 50%, we can call that soil. If the particle size between 4.75 to 0.075 mm, it is the particle size is between 4.75 mm to 0.075 mm is majority, that is more than 50%. Then even though that soil contains gravel and fine soil, then also it is called as sand. Then we call that as sand. Then if it is more than 50%, that is 4.75 mm above is more than 50%, we call that as gravel. Then we have to come this left hand side. Then we have to find out how much percentage is passing through the 75 micron sieve. So you should know how much is retained on the 75 micron and which particle is retained, as well as you have to know how much percentage of soil passing through 75 micron. If it is less than 5%, that is very meager amount, less than 5%, we can only through the gradation curve, we can define the soil either well graded or poorly graded. Say for example, if it is a gravel, if the fine content which is passing 75 micron is less than 5%, then it is well graded gravel or poorly graded gravel. Similarly for sand, well graded sand or poorly graded sand, the symbol will be SW and SP. Similarly for symbol for gravel will be GW and GP. If it is more than 12%, the passing will be more than 12%, then you have to perform the liquid limit test and the plastic limit test on the soil particles which passes through 425 micron sieve. So based on the result, you have to look into the A-line chart. Then what is A-line chart? We will see it is a plasticity chart wherein you will have one A-line. If your your soil thing falls above the A-line, then we call it as clay. If it is below the A-line, we call it as silt. So if it is above the A-line, we call that as GC, that is gravelly, that is clayey gravel. The adjective will be clayey and it is a gravel. Similarly, silty gravel, if the thing is on the hatched zone, we call it as dual symbol, that is clayey gravel and silty gravel combined name will be given. Similarly for sand, we can call it as clayey sand and silty sand. If your percentage passing through 575 micron is between 5 to 12, then we will have dual symbol. We have to perform this test also, liquid limit test also, liquid limit plastic limit test, as well as you have to perform gradation. And based on both the thing from GP and GC, this combination you will have GP and GC or GW or GC or GWGM or GPGM, like that dual symbol you have to do. Similarly for sand also you have to give dual symbol. For fine grain sand, you have to perform these Atterberg limits. The liquid limit will be a limit above which the soil will behave as a liquid, below which it will behave as a plastic. Plastic limit is a limit which above the water content, these are all water contents, above which the soil will behave plastic, below which the soil will behave like a semi-solid. And shrinkage limit is a limit which is above which the soil will behave semi-solid and below which the soil will behave as a solid. So if you find out water content of the particular site and you know the shrinkage limit, plastic limit and liquid limit, then you can easily find out in which state the soil will be presently available on the particular site. If it is more than liquid limit, for example, you are finding a water content of the site and the water content falls above the liquid limit, you can easily tell that the soil is similar to liquid and it possesses lowest strength. Some liquid limit and plastic limit values have been presented here. So for sand will be a non-plastic one. Silt will be in the range of the liquid limit will be range of 30 to 40, and the clay will be 40 to 150. Even if you take clay, again we can categorize by kaolinite, illite, and montmorillonite based on the mineral structure, structural content. Then this kaolinite will be lesser liquid limit, and when in compared to montmorillonite, even it goes to the liquid limit value will be even it will be more than 700. So similarly, plastic limit and plastic index also will vary. So based on this liquid limit and plastic limit, the chart which is there in the right hand side top corner, we call that as plasticity chart. The slant line which starts from 20 and it has an equation of IP is equal to 0.73 into W liquid limit minus 20. The line will follow this equation. This line is called A line. Earlier we have seen if my soil has a liquid limit, for example, I am having a soil has a liquid limit of 40 and my plasticity index is 20. So my point will fall on above the A line and it will fall between the WL35 and WL50. So in between this thing, I am getting a point. So if my soil is a sandy soil, then I will call it as clay sand, or if it is a gravel, I will call it as clay gravel. In fine grain soil, we have to see that where the point falls. If it falls, my liquid limit is less than 35 and the point above falls above the CL, that is A line, then I can call that soil as CL. If it is between 35, my liquid limit value is between 35 to 50, I can call that soil as CI. And if my liquid limit value is more than 50 and my plasticity index is sufficiently high so that my point falls on above the A line, then I call that as CH, that is highly compressible or intermediate compressible or low compressible, or sometimes they call it as highly plastic, intermediate plastic, or low plastic. Similarly, if it falls below the same line, A line, we call that as silt, that is low compressible silt, intermediate compressible silt, and highly compressible silt. And if it is rich with organic content, we call it as highly compressible organic soil, intermediate compressible organic soil, and low compressible organic soil. And my point falls in the shaded area, that is between 4 to 7, IP between 4 to 7 and above A line in this shaded area, then it will have a dual symbol. Then based on structure also we can classify. Say for example, depends upon the structure of the particle, shape of the particle. Angular, subangular, sub-rounded, rounded, well-rounded. See, which soil will have more strength? Automatically angular will have more strength and well-rounded will be having lesser strength, because our soil will have only shear strength thing. We do not have tensile or compressive strength on the soil particles. Then based on the structures, especially when it is in this is especially for the clay soils, single grain structures, then flocculent structures, then honeycomb structures. These flocculent structures, honeycomb structures, it happens because of the cementation of the particles between particle to particle binding, and the voids will be more. And the permeability, say for example, I am interested in permeability. The honeycomb structure will have more permeability than compared to other type of soil. In clay type soil, clay type particle, as we know, our clay particles are not rounded particles. It is a plate-like structures. It will be like a plates or rods. That flocculated types will be there or dispersed will be there. Flocculated means the voice will be more. Dispersed means it is get compressed and the voice will be automatically reduced. Then we have another undisturbed saltwater deposit and undisturbed freshwater deposits also will be there, depends upon the charges on the thing. One more property which will define the strength, we can, based on that we can understand some behavior which is called sensitivity. The formula for sensitivity is undisturbed strength divided by remolded strength. See, say we can, if say in this figure, the person is having a Leda clay which is been in Canada. If it is in the water content when it is very less or it is in undisturbed state, the strength you can see so many kgs of weight being put on the soil. When it is get disturbed or remolded, the same soil behaves as a liquid. So this gives you some idea about the how sensitive the soil is. And you have values. If the sensitivity value is between 1 to 4, it is a normal behavior. It is 4 to 8, it is sensitive. 8 to 15, it is extra sensitive. If it is more than 15, the soil will, we call it as quick. Another property of the soil is thixotrophy. Thixotrophy means it regains its when it is undisturbed, it will gain strength. When it is disturbed, it loses strength. Similar to your curd. Then we call one more property activity. For activity, we have a formula that is plasticity index by percentage of clay particle. How much percentage of clay particle? The clay particle size is lesser than 0.002 mm. So we have to put that percentage in denominator and we have to find the value. Differentiate inactive, normal, active, very highly active, all these things. And the table shows some values for kaolinite, elite and montmorillonite minerals, activity values. Activity is one of the factors used to identify expansive swelling characters of the soils also. If the activity is more, then the soil will swell more or shrink more. Then we have one more property, we call it as free swell index. We have to we have to put the sample, one sample similar same weight, one in kerosene, another one in distilled water. Then since the kerosene will not react with soil, so it will behave as an inert thing, so it will not swell. The particle which has been in contact with water will get swell and it will swell in free. So we will find the value between these volumes. Then we will present the value as a percentage. So degree of expansion of when the free swell is less than 20, we call it as low expansive. If it is between 20 to 35, you call it as moderate. For 30 to 50, we call it as high, and more than 50, we call it as very high. So consistency limits, we can classify the soil based on the consistency values also, that is strength values also. Then if my unconfined compressive strength is lesser than 25 kPa, we call the soil as very soft soil. This is for fine grain soil. And if it is between 25 to 50, it is soft. Then if it is more than 400 kPa, we call it as hard. So very soft, soft, medium, stiff, very stiff, hard. That is how we differentiate fine grain soil based on unconfined compressive strength. Then we have, for coarse grain soil, we have relative density. We are relating the density with the lowest density to the highest density. Then what is your state? So based on the formula is there, dr is equal to E max minus E divided by E max minus E minimum. E max and E minimum are the maximum and minimum value of the void ratio for the particular soil when it is being tested in the laboratory on identical in standard conditions. Then this E is the state in the present site condition. So it is E represents the site condition, then that site condition may be closest to loosest or it may be closest to densest. So for which we have to calculate the percentage. Then based on the relative density percentage, we can classify the soil: very loose, loose, medium dense, dense and very dense. This is specially for coarse grain soil. And we have some tabulation, and this we have already seen. Over 300 mm we call it as boulder. Less than 0.2 micron we call the particle as clay particle. Then we have OS2 classifications also, even though we don't use these classifications in India. I want to just give you a glance values for this. So they divide this total soil into 1 to 7, A1 to A7, based on the plasticity value, plasticity index and liquid limit, along with percentage pass through 200 sieve, that is 0.075 mm sieve. So if it is less than 35%, the percentage passing is less than 35%, the number will be A1 to A3, and if it is more than 35%, the percentage passing will be A4 to A7, and again it will be further divided based on the chart which is being presented on the right hand side. Why it is required? You have to communicate between engineer what type of soil that is it is necessary. It provides a systematic method of categorizing soil according to their probable engineering behavior. A classification system must be simple with less number of soil. Most commonly used properties are grain size distribution and plasticity values. The soil classification system does not eliminate the need for detailed soil investigation and for testing for engineering properties. Engineering properties means direct shear test or unconfined compression test, triaxial test, SPT test, or other tests and all. However, the engineering properties have been found to correlate quite well with the index and classification properties of the given soil deposit. These are all some of the soil and the corresponding strength parameters, how it will be good or bad. Some values has been presented here. I will go to road embankment construction. In that construction operation, generally what is road construction? Materials which is being used and its requirements. What are all the operations we perform? Then what are all the things which construction, how the construction of embankment being done, and the construction of subgrade being done, whether we can allow traffic or not, then what are all the quality control measures we have to do, we will see in subsequent slides. In general, the specifications, this is as per MORTH. Whatever I am saying here, this is I am already carried out from MORTH specification. So these specifications shall apply to the construction of embankment, including subgrade, earth and shoulders, and miscellaneous backfill with approved materials obtained from approved source, including materials from roadway and drain excavation, borrow pits, or other sources. Before I am going in detail, I will say what is embankment, subgrade, earth and shoulders, and other backfills. Embankment is a lowest earth portion. Even I can say subgrade is a foundation for your road construction. Your road cross section will be like this. You will be having a wearing coat on top. To support the wearing coat, you will be having a base course to support the wearing coat. The base course will either it will be bituminous base or non-bituminous base or combination of the two. If you take bituminous base, we call it as bituminous macadam or dense bituminous macadam and etc. etc. If it is non-bituminous base, we call it as wet mix macadam or waterbound macadam. All these two are called non-bituminous base course. Then we will be having a sub-base course for properly drain, or which will prevent the capillary rise and it will preserve the road surface. So that is called granular subbase, GSB we call that as. Below that GSP, we keep this subgrade. That is your foundation for your road structure. We call that as subgrade. So definitely subgrade will be given higher priority and better quality than your embankment. Embankment is a just rise and fall. You have to fill the undulations with the soil, some soil, good quality soil. So that portion is called embankment. So your profile will be made ready when you achieve your embankment top. So you will have a defined profile, longitudinal profile and a cross-sectional profile. So that is called embankment. And subgrade, earth and shoulder, you will have earth sides in on the sides of the bituminous hard thing. Then you will have sides earth. That is called earth and shoulders. And you will have materials behind the bridges, behind the retaining walls and all. You have to fill it with a quality soil. All embankments, grades, depth and shoulders and other backfill shall be constructed in accordance with the requirement of the specifications, conforming with within line, grade and cross section line or as directed by the engineer. Engineer means engineer in who will be site. What are all the general requirements? The material used in embankment, subgrade, in these fields and all, soil, muram, gravel, or reclaimed material from pavement. See, nowadays you recycle, you scrap the existing bituminous material, and reuse the same material in your fillings. Say, for example, even in subbase also we use. And fly ash, a mixture of this or any other material as approved by the engineer. The material shall be free of rocks, stumps, roots, rubbish or any other ingredients likely to deteriorate or affect the stability of the embankment. So these materials has to be removed or omitted when you fill. The size of the coarse material in the mixture of earth shall be ordinarily not exceeding 75 mm. So maximum allowed size of either even it is a clot also, then it should be a maximum of 75 mm for embankment, and it should not be more than 50 mm for subgrade. If it is more than 75 mm, either you have to break it to reduce it to 75 mm, or you have to remove it and throw it on the sides. The maximum particle size, however, shall not be more than 2/3 of the compacted layer thickness. So that is also will govern. Whichever is lesser, you have to adopt. The following types of material shall be considered unsuitable for the embankment. So material swamp, marshes and bogs, marshland and the organic material, all these things you have to omit. Peat, rock, stumps and perishable material. Any soil that classifies as OL, OA, OH, that is organic, low compressible organic, intermediate compressible organic. All organic soils and peats are should be avoided in accordance to IS 1498. Materials susceptible to spontaneous combustion, that is also should be avoided. Materials in a frozen condition should also be avoided, because the frozen material will have higher volume. When it gets unfrozen, then automatically the volume will reduce, and because of that settlement will occur. Clay having liquid limit exceeding 50 and plasticity index exceeding 25 also should be avoided. Even though we have clay, if the soil is having liquid limit more than 50, it has to be immediately rejected and we cannot use the thing. Materials with salts resulting in leaching in the embankment also should be avoided. Say, for example, if you take sample from your seashore, automatically it will be rich with salt. That type of material should be avoided for your embankment. What other considerations? Expansive soils exhibiting marked swell and shrink properties. If it is swell and shrink properties, means we have only free swell index as a index. So which is exceeding 50% has to be avoided as per IS 2720. And where an expensive clay having free swell index values less than 50% is used as a fill material, subgrade, and top 500 mm portion of the embankment just below the subgrade shall be non-expansive in nature, even though you can use as an embankment material, but this expansive material shall not be used in subgrade, and also the portion 500 mm below the subgrade, that is from the top of the embankment, in embankment portion, the top 500 mm thickness should be the expansive material should be provided. And these are all the criterias which is to be used for embankment purposes. Only density is being given, even though other things are being given in a thing, liquid limit and the free swell form. If it is a embankment is less than 3 meter height, then your unit weight of the soil should be 15.2 kilonewton per cubic meter. If your soil is more than that, then you can use. If it is less, then we cannot use. If the embankment exceeds 3 meter height, say for example in approaches of the bridges, then the unit weight should be higher, 16. For subgrade and earthen shoulders, the unit weight even higher, it should be 17.5 kilonewton per meter cube. This is called maximum dry density, that soil density has to be considered. This table is not applicable for lightweight fill, for a cinder, fly ash and all. This will not be applicable because fly ash and cinder will automatically will have lesser unit weight, for which you have to adopt different code. The material to be used in subgrade shall be non-expensive and shall satisfy design CBR at the specific dry density and moisture content. In case the available material fails to meet the required CBR, use of stabilization methods in accordance with class 403 and 404 of this code has to be used. For stabilization methods approved by the engineer shall be followed. So it has to be for subgrade, the material has to satisfy CBR thing also. If the CBR is less, automatically you have to increase the CBR either by stabilization, or you just remove, you don't use the material, go for a higher CBR material, search it and use it. Compaction requirement for embankment and subgrade. Even though you use the material, you have to compact it by roller. So how much compaction you have to achieve? If it is a subgrade and earthen shoulder, then you have to achieve 97% of the compaction, 97% of the MDD, maximum dry density, which is been calculated or found by using Proctor density test, standard Proctor or modified Proctor based on your requirement. So 97% for subgrade, 95% for embankment. If it is a clay soil, then top 500 mm it is not allowed, expensive clay. For below portion, for expensive clays, even your compaction can be reduced to 90 to 95 because compacting expensive clay, even clay itself will be a difficult one. The compaction will not be achieved easily because water will not cannot mix the water homogeneously. All these difficulties will be there, and we cannot use. We have to use specialized roller also for compacting clay soils. This is a typical type of rollers which is being used in the field. If first left hand side we have a smooth wheeled roller, but this roller can be used in coarse grain soil, and a impact roller also can be used in coarse grain soil. Impact roller to compact the ground. One more type of roller is the sheep foot roller, where the shape will be there, and that will be used for compacting clay soil especially. This will give you kneading arrangement and kneading effect to the soil, and the compaction will be achieved. Then how the operations will be, construction operation. So first you have to set out, then you have to strip the top soil. Compacting. What is setting out? So the limits of embankment, that is boundaries, embankment or subgrade shall be marked by fixing batter bags or marks, which is lime powder marks or something like that. You have to mark it on both the sides at regular intervals as a guide before commencing the work. The embankment or subgrade shall be built sufficiently wider than the design dimension so that the surplus material may be trimmed, ensuring that the remaining material is to the desired density and in portion specified and conforms to the specified side slopes. See, this is see, for example, in a lower thing, we require 12-meter width of embankment. We take an example. So for which what we do inside in practice, we will construct 13-meter embankment, that is 0.5 meter extra on both sides, because for rolling and all, compaction, rolling, watering, then grading, all these things require space. If you exactly construct 12-meter, then the end portion will not be that required density and property, strength properties may not be achieved on the boundary. So to take care of that, normally in site what they do, they will construct 500 mm or more than that extra width on the sides. Then after achieving a particular some height, the extra soil which is being constructed on the downside will be scrapped away and it will be utilized on the top layers. Preferably we will use that on the shoulders, earthen shoulders, when we do base and wearing coat. That is how we achieve the quality. Then topsoil, wherever we construct road, the topsoil will be rich in organic matter and rich in minerals, which will be very good for cultivating, that is putting grass and all. So this soil has to be preserved, and wherever it has to be required, we have to reuse it. So for which we have to stock it in a separate way, or we have to give it to the farmers where they are, if they require that soil. Nearby farmers, they can take that. Then spreading of material and compaction. The compacted thickness of the each layer. You have to dump the material by a dumper or tipper. Then you have to level it, grade it by motor grader or by manual or tractor or dozer. We can use any equipment according to the site condition. So the thickness should be, if you are using a vibrated roller, what score says, your maximum thickness should be 250 mm. And if you are using 8 to 10 roller, that is tri-wheel roller, 3-wheel roller without vibration, your maximum thickness should be lesser than 200 mm. So these are all the criteria they have given. So people, when they, some people know, some contractors, they will put 1 feet or 1.5 feet soil and they will compact and they will say, I am using heavy roller and all. So code does not permit all these things. So code final compaction thickness should not be more than 250. And that tray wheel without vibration roller, that has to be maximum of 2. The water shall be sprinkled from a water tanker fitted with sprinkler capability, and it has to be spread to full width wherever required. If the water is required, it has to be added. How it will be added? You will know the OMC, optimum moisture content, and if you test the existing water content of the soil which is being dumped, you will know the difference in water content, and we will know the weight of the soil also which is being dumped. Based on that, we will calculate how much liters of water which has to be spreaded, and we will tell the tanker to dump the water, required quantity of water, by moving the tanker 2 1/4 on the surface of the soil. Then if it is a coarse grain soil, there will not be much difficulty. Automatically the water will percolate to the lower portion. Then homogeneity will be achieved. If it is a clay content is more, then water will not percolate. Then you have to use either a disc arrow arrangement or tractor arrangement. Then you have to mix the soil from top to bottom, and then you have to compact it. So in water content, moisture content of the each layer of the soil shall be checked in accordance with IS 2720. At the time of compaction, the water content shall be in the range of 1 to 2% below the optimum water content determined according to 2720. 2720 is the code for standard Proctor test. Or if you are using modified Proctor, then you will get that code specifies that particular Proctor density and Proctor OMC. So code says here you can see it, you have to use dry side optimum, that is you have to use the dry side optimum water content, that is 1 or 2% lesser, and it should not be more than optimum water content. Clots and hard lumps of earth shall be broken so that we have 75 mm and 50 mm size for embankmented subgrade. A typical figure which will be shown as a watering, a water tanker waters, sprinkles water on the surface. In another figure on the right hand side we can see a disc and disc arrangement connected to the tractor or equipment horse, which will mix the soil from top to bottom so that homogeneity in the water content will be achieved. To determine the water content, you have various methods. Normally, mostly we will do pan frying method. That is a customized method which is being adopted in the site. Or you can go for calcium carbide method, which is an equipment. We will be having a cylinder. Inside that cylinder, you have to put standard weight, specific weight of soil content and specific weight of this calcium carbide. So both the things will be put inside along with the steel balls, and it will be tightly sealed. Above the cap, there will be a pressure gauge. When you shake the this chemical calcium carbide and soil, when you mix the soil, this chemical will react with the water, and the gas will be formed inside the cylinder. Because of the gas, there will be some pressure. That pressure will be, you can see that quantity of pressure from the dial gauge, which will be correlated, and it will be directly correlated with your water content. So more will be the water content, more will be the pressure created, and more will be the dial gauge reading. So you will be having a chart along with that calibration chart, and from the dial gauge you will read that reading. Corresponding dial gauge reading, you will have the percentage of water content on the chart. Another method is oven drying method, which is a laboratory method. Sandbath method, which will be normally practiced mostly in the site, or we can even pan fry also. Because we are not going to use the same material. So normally we will do pan fry method. So even though the structures getting changed, it will be easy for us to do pan frying. Then you have one more method, radiation method, based on the radiation technique, nuclear technique. So you have equipments which will, per radiations will be passed. That equipment has to be kept on the surface of the soil. Then that radiation results, and it will be calibrated. According to that, you will know the moisture content. Another one method is alcohol method, which is not being used on the site. Then you have compaction. You have three-wheel roller, self-propelled single drum vibratory roller, which is we have seen just now. Tandem vibratory roller. Tandem means both the sides you will have the vibratory drum. That is called tandem vibratory roller. Pneumatic tired roller. Pneumatic means it will all the roller total width will be is a tire combination. So we call it as pneumatic tire roller. Pad foot roller, which I have seen for clay soil, sheep foot roller or pad foot roller. Suitable size and capacity has to be selected as approved by the engineer, shall be used for different types of grades of materials required to be compacted either individually or in suitable combination. Then how many passes you have to do, how much time you have to compact, how much weight of the roller has to be used. All these things you have to perform a trial stretch before you do the actual road construction. You will do a trial stretch wherein you will do all combinations. Then you will finalize this type of roller has to be rolled this much type of this many number of passes, all these things to be finalized to achieve the required density, and it will be subsequently checked by density checking also. Whether you can allow the traffic or not, you should not allow the traffic on the embankment or subgrade, but you can allow construction traffic in such a way that it should not affect the surface of the formed layer. This is another grader which is being used to spread the soil which has been dumped. And as right side you can see one was a single drum vibratory roller, another one is pad foot roller working on the site. Then quality control, borrow area material. How in borrow area you have to test. In the borrow area has to be made a grid of 25 meter to 25 meter, and each test has to be done in each 25 meter. The following test representative sample should be carried out every 3000 cubic meter for each source. So even though it is 25 meter by 25 meter, so the quantity should be 3000 cubic meter. For each 3000 cubic meter, all these below test has to be conducted. If it is a sand content test, you have to do 2 tests per 3000. Plasticity test, you have to do 2 tests per 3000. Density test, that is modified Proctor or in laboratory, you have to test 2 tests. Deleterious contents of harmful contents, as and when the engineer asks. Moisture content test, 2 tests. CBR test on material to be incorporated in the subgrade on soaked and unsoaked samples. 1 CBR test, 1 CBR means average of 3 specimens, or closer as and when required by the engineer. So all these tests has to be conducted in the borrow area material. Then if it is laid, then you have to check the density, laid density even after compaction. There are so many density meters. The nuclear density, nowadays nuclear density test equipments are being available based on this gamma rays. So you will be having a rod wherein you will have the source, nuclear source, and that radiation will be absorbed by a Geiger-Müller tube which is been available inside the equipment. So the right side figure you can see the radiations are being passed through the thing, and it has been received in the recorder. So the it is being calibrated using a known density. Normally we will use a density cubes, concrete cubes, to calibrate these nuclear density gauges. Then we will use it in the soil. Okay, and normally the concrete density will be 25 kilonewton per meter cube. So for which we will calibrate, and because the soil density will be between 15 to 20, it will be automatically, it will come correct. Other types of sand replacement tests also we can do, for which you have some sand replacement cone, tray, weighing machine, water moisture content thing and all. Then quality control. During the construction, you have to adopt some quality control measures. Then control shall be exercised on each layer by taking at least one set means 10 measurements of density for each 3000 square meter compacted area or closer as required to yield a minimum number of test results for evaluating a day's work on statistical basis. So one test means 10 tests you have to do for each 3000 square meter. That is one test for 300 square meter. To determine the density shall be in accordance with 2720, that is sand pouring cylinder or density gauge. Test location shall be chosen wherever you are finding, you think that it is vulnerable, you have to choose that location and you have to test that. If non-destructive tests are carried out, that is if you are using this nuclear gauge test and all, then your number of tests should be doubled. Instead of 10 tests, you have to do 20 tests for 3000 cubic meter. If you found considerable variations, you have to increase the number of tests so that you can achieve the standard deviation. However, for earthwork in shoulders and in the subgrade, at least one set of, that is one set mean density test measurements shall be taken for every 2000 square meter for the compacted area. In road construction work, the requirement for embankment construction and formation of subgrade, following parameters have to be monitored. Unit weight of the soil, as we already know, that has to be taken care. Relative density, relative compaction 97 or 90 to 95%. Then layer thickness should be less than 250 for vibratory roller and 200 for plain rollers. Water content should be on dry side of the optimum moisture content, that is 1 to 2% lesser. Why 1 to 2%, sir? Can I do for exactly optimum moisture? Yes, possible. If you can do, you can do. Why you are keeping 1 to 2% lesser? You should not exceed that. You cannot roll your material on the other side of the optimum moisture content. That is the intention of to keep the moisture content little bit lesser than the optimum moisture content. So again, liquid limit should be lesser than 50, plastic limit should be 25, not exceeding 25, free solid will be lesser than 50%. Then subgrade, it is not permitted free swell. Size of the coarse material should be 75 for embankment and 50 for subgrade. These are all the conclusions based on the presentation. Then these are all the references. If you have any questions, you can ask or conclude.
Thank you, sir. Thank you, Kishore, sir. So participants, those who
Thank
have
you,
any
ma'am.
question, you can just post your question in your chat box. You can just raise your question there. Sir, I think one person named Balakrishnan has already posted his question. Can you able to see, sir, in the
Yeah, I
chat
have
box?
to.
Yeah.
As per IS 1498, size of gravel between 75 mm to 4.75 mm. In your presentation, mistakenly, maybe mistake. If it is there, I will correct it. I have taken it from book. Maybe you may be right.
You can just post your question in a chat box. Any other question, participants?
Yeah, plasticity index limit has to be followed, strictly followed. It should be lesser than 25 for your construction work. Because see, you have to be less. Even though when I told that the soil properties, activity, sensitivity, thixotrophy, nothing is being followed in road construction. We have two, three parameters only we are taking it, and we are nowadays only they are doing cyclical test and all, cyclical test on subgrade soil. Then based on that, design parameters is being changing. So nowadays they are doing advanced testing. Earlier, even now, based on more revision 5, we are adopting only liquid limit, plastic limit based on that plasticity index and free swell and swelling characters. No other governing things. That is why you have very strict parameters which has been given, guidance being given. What are sudden accidents which have to be faced during embankments and subgrade formation? Mostly the vehicle, the grader and roller will get toppled. When you construct embankment, that may be the sudden accidents. Other things mostly nowadays other accidents not happening because so many precautions they are taking. Reverse horn, when the grader getting reversed, and driver cannot see the backside of the motor grader. So such accidents might have was happening earlier. That has been prevented nowadays because of innovations in technology, mechatronics, because like reverse horn, beepers, and other things. Earlier, such accidents were prevailed, and these accidents is you cannot avoid. See, sliding off when you take a grader to the end, one side of the wheel will be on the looser portion. That may happen. That happens most of the time. Can we use rock as an embankment material? Yes, you can use rock as an embankment material. When you are cutting a hill portion, you will get rock as a. You can have a subgrade also. Why you are keeping a rock as a embankment material? You can keep rock as your subgrade, even above the material. It will act as a solid portion for your road to receive the road structure. How we get the PPT for future reference? I will post this PPT. I will send the PPT to the organizers, and you can get it from them. Can we use rock as an embankment material in roads below subgrade? No, you cannot use rock as a. I am understanding that if you are telling rock means it is a rocky boulders. You are telling such material you cannot use, because you cannot uh, control the quality of the formation. If you use boulders, erratic thing, you cannot compact it, you cannot fill it, you cannot grade it. So such material, if it is a formation, full rock formation without disturbance, you can use it as a embankment surface, not as an embankment material. You have to break it to less than 75 mm, then you have to use it. Any other questions?
Any other question, participants? So I think the questions are over, it seems, sir. Kishore, sir.
Okay, ma'am. Thank you.
Thank you, sir. Thank you for your valuable time.
Thank you, ma'am.
Thank you, sir. So participants, meanwhile, while we start the second session, you just please fill your feedback, which is posted in the chat box. The link is posted in a chat box. Please submit your feedback. Sir, Rajan sir, I can't able to hear your voice, sir.
Now, is it okay now?
Yes, sir, now is audible.
Yeah. Thanks a lot, Kishore sir. It
Thank
was
you,
a
sir.
wonderful session. I think you have almost replied all the queries. Feedback link is sent, so all participants please fill the feedback forms and send it back as early as possible. And Dr. Satyajit Patel is already in. He is going to handle the session 2, and hope all of you will be available for the session 2, and followed by it, Dr. Balakumar will be presenting his session after the lunch. That is at 2 p.m., the third session. Thanks a lot. Welcome, Dr. Ilango, sir. Thanks for joining our program. Dr. Ilango, HOD from Valime Engineering College, and all others who have joined based on my request. Thanks a lot to all the participants who was making this session very successful. Dr. Lakshmi, everybody, Dr. Mansha, all who are able to. I'm sorry, I'm able to see certain people. Dr. Satya, ma'am. So whoever I am able to see here, I am just welcoming. Who are well known to me. Thank you very much, and thanks to all the participants for joining this wonderful session. So I hope that all of you will be staying back for all the 6 days. Please fill the feedback without fail. We'll be posting now, and again also we'll be posting for those who are missed due to your additional works. You'll be handling some other works also in between, and you can handle your work as well as attend the session. I think you can do that. And all of you have some academic works also. I know very well as faculty, I am also having the same problem. We'll be conducting internal, online laboratory examination, project papers, all these things are there held. And I know Dr. Elongo has his project Viva examination right now this week. So with all this, when people are joining here, it shows the interest and the kind of love and affection you have with me. And hope we'll make this all the sessions successful. And let it, I hope this will be enriching your knowledge, and it will be giving enough enhancement to your already available knowledge in the road industry. Thanks a lot. Let us join the next session at 11:30. Dr. Satyajit Patel, sir, can you please, it is just attendance code is just a number, sir. You can just type it and go ahead. Dr. Satyajit Patel, can you say hello, sir? Are you available? Dr. Satyajit Patel, the speaker of the next session. Sir, are you available?
Sir, I think sir.
Left. He said he's there. I just made him a call.
Okay, sir. Okay.
He said I am in already. We'll wait.
Oh, okay, sir. We will wait.
Just now I made him a call. He said I'm already there in. We'll just wait.
Okay.
Okay.
Okay,
Fine.
sir. So participant, meanwhile, please submit your feedback, which is posted in the chat box. The link is posted along with the attendance code also. So please see in the chat box. So we just wait for 5 to 10 minutes to start the second session.